In the companies, always every company follows the same structure. The tables are stored in the OLTP, and normally the tables are stored in OLAP. So previously, what is OLTP and what is OLAP, I am going to explain. Okay. Now we will go with the OLTP only. OLTP. So previously, how the data is stored? They don't have any relations between the table, and just they used to store the data. Okay. So in the OLTP, normally the tables will be maximum times it will be the normalized tables. Okay, I'll not cover the normalization in depth, but I'll give an example for that. So what is normalization? Let's say I got one table. The table has student ID, the table has student name, the table has class ID, which class is registered, the table has class name, and it has like marks, student marks. Okay, student marks, STME. Okay, I'll just write marks. So this is a table that I am having. Student ID 101, 101, 101, A, and class ID is 101, 102, 103. Class ID is science, social, and it is having some other called maths. Marks is 20, 30, some 40. It's for 100 or it's different. It might be of 40 out of 40. Okay, this is the thing that I am having. See here, I stored the data. Even though I don't want this student name, because I might have multiple student 102 BBB, the same I am having two structures 101, 102, 103. Again I store the science, again I store the social, again I store the maths, the same. Even I am storing the name here again, the same student name I am storing again here 2 times. I am storing for this 2 marks, and here I am storing 3 times, right? This is normal. So when we do this like normalized, I can do it normalized means breaking a table and giving a relationship between them. Basically, whenever we can say that tables are normalized by default, when it satisfies up to third normal form, minimum to minimum it should satisfy up to the third normal form, then we can say that the tables are in the normalized way. Okay, so after the third normal form, the tables will be this way. I can write it, I can create one table as student ID, student name. The table will have just 101, 102, AA. Next, I can create one more table. I am breaking this table, CID and CNAME. This table will have 101, 102, 103. It will have science, social, maths. Then I'll have one more table called marks. So that table will have the student ID, CID, and marks. Okay. See, student ID 101, like you can just remember, you can imagine what the marks will be like, okay, right? So now the CID will be related to this one, and the student ID will be related to the student ID. So the primary key will be student ID and CID and the marks table. So I break. See how easy it is. So I'll write that one here: student ID, CID, and student name. The student ID will be the 101, 101, 101. Class ID will be 101. 102, 103. The marks are 20, 30, and 40. See, instead of storing the 5 columns, I have just stored in 3 columns, and I have created multiple tables. So here the duplication is ignored. Instead of storing the name 3 times, just will store only one time, just the student ID, and the names are stored in other one. If you want to get the name, just you will join with the student table and get name. Same with the class table. Instead of storing the class name again and again, just we are storing only one time. In the class name, if you want to get the class name, just you will join and you will get them. Because for the student ID 2 also, again we need to store the class name, right? So we will not store, just we will store on the class ID. If he wants the class name, just you will join with the class table, and we have seen the joins. If you want to get data from different tables, just you will use the joins. Okay. So this like breaking the tables into different, and is an easy way to maintain also. Here if you want to update the student name to some name, that let's say that student, instead of social, let's say the class name. Instead of science, you want to update to some science or only biological science or something like that, then you need to update all the records. But here just you need to update this one. When you break the tables into different things, just you will update only on the class name. Only one record you will update. Automatically it will be reflected, because you will join that and you will get them. How easy is it, right? So normally nowadays every company will the company may have the non-normalized, it may have the normalized table, it depends on that, but basically by default maximum of the company will have the normalized tables, that is in the OLTP. Okay, that is that it will have the normalized tables in the OLTP. So everyone is okay, clear with this concept, what is the normalization?
Yes, Bhaskar.
Yeah. So normalization, you will be having normalization, one normal form 1, normal form 2, normal form 3. Normal form 1 means taking a tables, normal form 2 and 3 means you will be creating a relationships. Okay, that you can go and see, it takes more time, just you can go and search in the Google. But the normalization concept is nothing but breaking the tables in such a way that it is easy to store and easy to maintain. Okay, easy to store and easy to maintain, like updating. If you want, instead of updating all the records, just you can update only one record, and you are not showing here all that class name again and again, just you are showing the class ID, that's it. And it also saves the space and it is easy to maintain, like that's it. So now we will go in depth. So my company, I got the OLTP database, and that OLTP database having the normalized tables. Okay, normalized tables. And what I will be doing is that I will be having some applications which I will be loading the data into that normalized tables. I will be loading the data into the normalized tables, and I have established my company in 2000. Done. I have established my company in 2000. Done. Every year I will be getting like 10 million records. Every year my company, I'm adding 10 million records every year. So in 2000 I got 10 million records. And one more thing, whenever there is 10 million records, suppose let's say in the same way in the dictionary you might be seeing, right? If in the dictionary, if you have only 10 records, in the dictionary if you have only 10 records, how easy it will be, like you can easily find it within fraction of seconds. You can find that, let's say in the dictionary you got only 10 words, and if you want to find some one word, it will be easy to find one word out of 10 words, you can easily find, right? Let's say you got some millions of words in a dictionary, and if you want to find some word, even though the data is sorted, but you need to go to that word, and again you need to go to that second letter in that word, and then you need to do, right? Like it takes some time. That's it. When the number of words get increased, it takes some time to find the exact word. Same way with the database also. Whenever you want to, if you write some select statement, if it 10 million, it may take 10 seconds. Let's say if you have 20 millions, it will take 20 seconds. When the size increases, the select statement also will take more time. If you want to update the data, it also takes more time when increasing of the size. Okay, when the size, at the same time there may be the end users, because we will be creating some reports, right? I will be explaining about the report. There may be some end users who wants to see the total data at the month level or year level, and they will be building some reports. Okay, and at the same time they will also access the table. So because of that, they will be able to access the table, and here they will be trying to update the same table. When two operations wants to do when there are multiple operations, when there is some multiple operations want to do something on the table, on the same table, then you can't do, it will become a deadlock. Only one operation can perform on the table at a time. Okay, you can perform like, you will be seeing about them later on. Okay, it is nothing but there is isolation level. So the isolation levels we are going to explain about that. You can see read committed, read uncommitted, repeatable read, serializable read, snapshot read. Okay, there are like many isolation level we will be covering at the end. So let's assume that multiple people cannot do the same thing, because if you have one dictionary, how many people can read the dictionary at the same time? No, right? In the libraries they will be having books. After one person is done with the book, then other people will be taking that book to read. It is not like you took the book, and if someone wants to see that book, you will come and see, if you will come and read the book at your home. No, right? You will be reading the book. Once you are done, then other people will be using that book. Okay, so same way in the tables also, other process, multiple things you can't update, you can't delete on the same table at the same time. Either you can do update, either you can do delete, like that. At the same time, when you are deleting, if someone wants to get the data from that, you will not be getting. Once the delete operation is completed, then you will be getting the data. So like it's like performance on the same table, you are using many things, right? And here now it is 2000. Now after in the 2010 year, I'll be getting 100 millions. As I said, every year I'll be adding 10 million, so I'll be getting 100 millions. So in the 100 millions, I'll be having a 10 years of data. In the 10 years of data, even you might be seeing, like, if you go to the Walmart, okay, in the Walmart, you'll buy some item. So you may buy any item, and if you call to the customer care and if you use a transaction, then you might be saying, okay, this is the transaction, so these are the items you bought. Then you might say anything regarding that. But how long the transaction ID is useful? So after 1 month, you got one return policy in the Walmart, so like they will be saying some 5 years warranty. But you might, let's say the Walmart has a maximum of 5 years warranty. So you can return the item or you can replace the item up to 5 years. So your record, so you did some item, let's say this is a Walmart, okay, you are inserted that item with the transaction ID. So the same transaction, so if you want to delete, update or insert, or if you want to update the transaction, like you can return item, and in between the 5 years warranty time, you can go and replace the item also. So until that 5 years, this record they can modify, they can update the record up to only 5 years. After 5 years, they don't need the record because the warranty is done 5 years. You can't even return the item, you can't replace the item also. So the transaction is not going to be used after 5 years, but still that is there in the database. So out of 100 millions, only 50 million records may be useful, not the 5 millions records. It is 50 millions record, like previous 5 years, like before 2006, that records you might not be used them, but still they are there in the database. So when you add the data, when you add in the database, by default it will reduce the time for updating, for inserting or for selecting. It will take more time, even though you are not using the 50 million record. And you may get one idea, so you can delete that 50 million records. You might get some idea, like, can we delete that 50 million records which are not used, but you are not going to delete them because you need some backup for the 50 million, right? In future or sometimes later you might need them, or you might just get the, like, I want to get total sales for 2000. So when you want to get the total sales for 2000, then definitely you need to go and check that, count that 2000 records, right? The records which you inserted in 2000 year. Okay, so for this purpose, normally this is a OLTP. So then there comes a concept called OLAP. Okay, what we do, so this is a OLTP. So in the OLTP we got the data, and again we'll get the concept called OLAP. In the OLAP, just we'll currently have with the relational OLAP. Okay, so there is a one concept called relational OLAP. In the relational OLAP, what they do, in the OLTP the tables are normalized. Okay, and we will be having many tables. So the same thing, how many tables have we created? We created 3 tables, right? We created 3 tables for them. So when the number of tables increased, so if you want to get student name and class name, you need to join with 3 tables and you need to get the results. So there is one disadvantage with that. If you join 3 tables with them, then as the number of tables you join, then the query performance also will decrease, because you will be joining with multiple tables, right? That record should go and look at in each table whether based on the conditions. So multiple join conditions should execute. So it will take more time. So as the time being, you just understand that you are going to just do little bit denormalization. Denormalization means, again, if you have 4 tables, what is the normalization? Let's say we got like 1 table, right? We have breaked 1 table into 3 tables. That is a normalization. What is denormalization means? Combining these 3 tables into 2 tables. Even the 2 table are combining this all 3 tables into the 1 table like the previous one, that is also denormalization. But we don't do entire denormalization. We'll just little bit reduce the number of tables. If it is 3 tables, just we reduce into 2 tables. That is a denormalization. Okay. In the relational OLAP, the tables are stored in the denormalized, little bit denormalized to the OLTP tables. Okay, little bit denormalized, not exact entire denormalized. It will just do little bit denormalized into the rollup. Okay, in the rollup we are going to see the concept later on. So what the people do? So here you got 10, 100 millions, right? The records which you will not use, that records will be loaded into here. Like they will load all the 100 million records here. Okay, what are the 100 million records you have, they load into the OLAP, and after that they will delete the 50 million records from here. They delete the 50 million. So now the OLTP will have just only 50 million, and the other historical record, the previous records less than 2006 will be loaded, will be stored here. It will have all the records up to 2010. Okay, it will have all the records up to 2010, but this OLTP will have only records up to 2006. It will have the records between 2006 and 2010 or the current, up to current. Okay, that is the thing the OLTP will have. OLAP will have all the records. So now the people, those who are going to perform update and delete, they will just perform on this, and the people, those who want to see the data, if they want to just view the data, the IN manager or someone, the vice president, they want to see total sales, then they will go and access this. Now the thing, you are breaking that usage into two groups. The people who are going to directly insert, they will be inserting the end users, those who are inserting the data. Users means the applications. The you are doing some transaction, you bought some item and you are doing the you bought some item in the Walmart, then that item transaction ID will be inserted into the table, and the manager who wants to see total transactions, then he will use the OLAP instead of going to the OLTP, because if many people are using the same thing, it is nothing but the 1 minute. Yeah, sure. Yeah, 12 కి కాల్ చేస్తాను, 12 కి మాట్లాడుతాను. నేను నాకు గుర్తొచ్చింది మనీష్తో 12 కి మాట్లాడుతాను. Okay, so we are breaking the usage into two. The people who want to insert the data, they will be using the OLTP. The people who just want to see the data, they can directly query from the ROLAP. So the process is being spreaded, and the people who are inserting, they can easily insert, they can easily update, they can easily read it, because it has only the few usage, the records which you are going to use. That's it. Okay, and now one more important thing. So how the data is going to be? So you are inserting, you are loaded the data up to today, like you are loaded up to 7/19. Up to 7/19 you loaded all the data into this database, and on the 7/20/2014 you will be having some records here. Then how you are going to load that record? You need to update that records into the OLAP, because if someone wants to see the day records, how many transactions I did up to today, how you are going to do? So for loading the data, all the whichever records which are recently inserted into the table, that all records you are going to load into the OLAP by using SSIS. Okay, just only the records which you add them recently added, only that records only you will be inserting, because you can't insert all the records, it will take more time, right? It is also no use. The records which are updated, which are inserted, which are deleted, that all records you are going to take recent records from here, and you are going to load into the OLAP. That all you can do by using SSIS. Okay, this is a concept. So now see the difference between OLTP and OLAP. So in the OLTP and OLAP, in the OLTP you may or may not have the historical data, because if it is less database, if the size of the records are less, you might have the historical data in the same OLTP, but if it is huge, then you might or you might not have, right? But in the OLAP it will always have the historical data, it will have complete data including historical data. Complete data, make a note, complete data including historical data. Okay, complete data including historical data. That is a major difference. And one more thing is that in the OLTP the tables are maximum, they are normalized. So you will do different, you will little bit denormalize them to form into the OLAP. Okay, then that is the second difference. And the third difference is that OLTP will have up to date. If I insert some transaction, first if I buy some item in the Walmart, the first thing the record will be inserted here. After that we will write some packages, we will create some SSIS package to load the data from OLTP to OLAP. We might write hourly basis or day-to-day basis. Okay, so we load the data in every hourly. So what are the records we added between last time load and now, it will take that records and load. So OLAP will not have in the OLAP the data is not up to date. It might, let's say we are loading a data every 1 hour. So it will lag up to every 1 hour data will be lagging here. Okay, everyone is clear with this? Hello?
Yeah, Bhaskar. Yeah,
So
Bhaskar.
in the OLTP the data will be up to date, but in the OLAP the data it will not be up to date. It will be like one, if you load every nightly, then it will have only up to last day. Tomorrow it will have up to today. Day after tomorrow it will have up to tomorrow. Okay, that is the major difference between OLTP and OLAP. So now we will go with the OLAP. There are again two types. Okay, OLAP there are two types. See, OLTP means online transaction processing. I didn't explain about this, right? OLTP means online transaction processing. OLAP means online analytical processing. Analytical means basically you will be using this data for analytical purpose. Okay. So in the OLAP we have seen ROLAP. Okay, and there is one more called MOLAP. Okay, what is ROLAP? We have seen the thing which we did, we just denormalize the table and we load into ROLAP. In the ROLAP we will store every record will be there in the ROLAP. Let's say if if the client or if some vice president they want to get the total records per year wise, 2000 from 2000, 2001, 2002, and they want to get the total year for 2010. Total records, that like total transaction. You might have some 2000 to like some 3 for 2000. As I said, you will be having 10 million transaction. Same with every year you will be having 10 million something. And if I want to get the transaction year 2000, and if I want to get it 2000 like quarter wise, so I need 2000. I need to get quarter 1, quarter 2, quarter. Let's say we got 4 quarters. I will get quarter 1, quarter. Then that 10,000 records will be again you will be writing. So I got 2.5, 2.5. Let's say it got divided in all the quarters, 2.5 million, 2.5, 2.5 million. So again you need to calculate them. So for doing this all functions, what you do normally, you use aggregate functions on the table. Okay, you use aggregate functions. So aggregate functions means it will take more time. It is not easy. Aggregate function means it will take more time. You can't so whenever you do aggregate function means the first thing it will take all the records for 2010, and after that it will sum all the records. So that is nothing but the aggregate functions. So you need to use aggregate function. Even see, for the same thing you might run the same query 100 times. So 100 times, if each time it takes 10 seconds, so 100 times means it will take 100 into 10 seconds. So the thing is wasted. Is there any scenario where if that aggregation is pre-calculated and stored in some table, so you can directly use them? Is there any scenario like that? Because it is already pre-calculated, and so that you can directly use the pre-calculated aggregation values, 2000 year wise and month wise or quarter wise, whatever you want. Already they are pre-calculated and kept stored at one location. You can directly use them. Is there any scenario like that? Yeah, we got one scenario called MOLAP. So that is a multi-dimensional OLAP, multi-dimensional online analytical processing. This is a MOLAP. So what they do here, whatever want. So here you will have the detailed records which every transaction, but in OLAP it will just have the eye level records. Okay, it's like you will call this concept called cube. The data will be stored in the eye level format. Okay, let's say this is a year. I can just take like multiple things. So this is like month, and this is the amount, and this is the year. Okay, combination of all like this one. So this file will have the details about the year. This files will have the details about the quarter. This like, so this file will have details for 2010. This file will have details for 2011. This one will have the details for 2012, and this one will have the details for month, quarter 1, let's say quarter 1, quarter 2 and quarter 3, like this. Same with quarter 1, quarter 2, like that. You will be storing the pre-calculated data for entire 2010. You can store for entire year. You can store entire for 2000 like quarter, year, and combination of year and quarter. You can store combination of year, quarter and month. Okay, like based on it the values will be pre-calculated and stored, and here you will not be having the detailed record. Let's say I got 10 million records in the year. Okay, I'll have all the 10 million records in the OLAP, but I'll not have all the 10 million records in the MOLAP. Just I'll have the total count as 10 million records per the year. That's it. I'll not have the detailed records in the OLAP. So the users, whoever wants to get the data, same data, so it takes 10 seconds here, because they need to calculate and they need to give. But even though they are calculating the same thing again and again, but in the MOLAP, you will just calculate and keep. Whoever wants to get, they'll just get from the MOLAP now. It might take only 1 second for them to use them. So now whenever they run, they take only 1 second. Whereas 100 into 10 seconds means it will be taking, like if you run 100 times, you will be getting 1000 seconds. But here just you will write 100 times, you will take 100 seconds. So it is like 1 by 10 time, right? So like 10 times that the query performance is increased here. That is a MOLAP. So in order to load the data from OLAP to ROLAP to MOLAP, so in order to create MOLAP, you will be using SSIS. Okay, by using this by based on the ROLAP structure, you will be creating MOLAP. We will be studying them later on. So everyone is clear up to here? That's it. That's the only thing that we are going to do. I am going to stop the recording this video.